And here we are back with part 3. So zeros of a polynomial function are the roots of the function or the values in the domain that make the polynomial equal 0. There are several names for this thing. So sometimes these are called zeros. Sometimes they're called roots. Sometimes they're called x-intercepts. And sometimes they're called solutions. So those are the 4 names that you could have for these different things. So there are several ways you can find what your zeros are. One of the ways is by simply looking at your graph. So we can see right here by looking at the graph that we have a lovely 0 at x equals -2. Beautiful. You can see that in the table because on the table it shows us that the x value is -2 and the y value is 0. So you've got those 2 places. Now the other 2 are not so obvious. We can look at our table or look at our graph and we see we have a number here somewhere between -1 and 0. And we have another number between 2 and 3. So to calculate what those zeros are, you would have to use your calculator and calculate the 0. Or you could type the function in Desmos and hover over where the zeros are, because Desmos will mark your intercepts. Okay, so I have this table over here, and what I can see on my table is that when I look at the table, so I'm looking at my y values, negative, negative, 0. Okay, positive, 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 negative. So somewhere right here, I have a 0. And if I look over here, I can see that it's between -1 and 2. This just narrowed it down between -0.5 and 0 because of it counting by 0.5s. Then I keep going again, negative, 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 positive. So now I can see that somewhere between 2 and 2.5, I have another 0. So if I want to calculate what that 0 is, easy peasy, lemon squeezy, I go to my Desmos. I typed in the equation, which was y equals x cubed minus 5x minus 2. And you can see they have labeled for me key points, right? So I just want to change my y min to maybe be -10. And maybe make my y max 10. Just so that I can see those points, okay? So bam, chicka wow wow. So as I look at this, remember all of our key points are labeled in Desmos. So there's my 0, a relative max right there, a relative min right here, another 0, 2.414, and if we go back to our answer, we said it would be between 2 and 2.5, so we've got 2.4140. That's one of our answers. And then if we go back to our graph, our other 0 appears to be here, and it should be between -0.5 and 0, which is -414. So that would be our other one, which was -0.414 and 0. So we have 3 zeros. Degree was 3, because our equation was y equals x to the 3rd minus 5x minus 2. I'm telling you that. Tomorrow we'll figure out how to find it. But to find that graph, bam, and now we have our 3 zeros. Okay? So now let's talk about how we can apply these problems. So what's in the box? In other words, what we're going to do is we're going to make a box that you can make from a regular sized piece of cardboard. The cardboard is going to be 80 centimeters by 60 centimeters. And what we want to do is we want to fold this into a box. So we're going to take this flat sheet. Oh, there's a card. I don't really want to use a card because that's from, somebody I love. Yes, I love people. So we're going to take a card or a sheet of paper, and what we're going to do is we're going to turn it into a box. So what happens then? Well, I'm glad you asked. So what we're going to do is we're going to take this box and we're going to cut the box, the corners out of the box. So I'm just going to fold my box so that I can cut the same out of each spot here, so you can see what we're actually doing. Okay? So what we're going to do is we're going to cut our box. So we took our paper that was rectangular, and now we have it set up so it can be a box. So if we fold this part over, and we fold this part over, and we fold this part over, and we fold this part over, what we have is a box. Okay, kind of like what you would use if you bought canned sodas or maybe at Aldi's. So that's the kind of box we want to do. What we want to do is we want to figure out what this cut needs to be right here. We're looking for what that cut needs to be, and we're going to cut squares. So even though mine was just kind of haphazardly done quickly, we're going to cut the same out of each one. So we want to find what the biggest box we could make here out of this dimensions are. So in order to do that, we're going to cut these boxes. So to figure that part out, we've cut our x's, and now what we need to do is decide what our length, width, and height are. Well, our height is x. Our height is x because that's how tall our box is going to be. So when you look at our box, the part that we cut is the part that was folded up. So this part right here is the part where I cut, so that's my x. My width is this part right here. So that was 60 from here to here, right? So I took an x and an x, so this is going to be 60 minus 2x. So that tells me that this part, my width, is 60 minus 2x. Now my length, right here, that was 80, and again we cut an x off of each side. So that's going to be 80 minus 2x. So that tells us that this part is 80 minus 2x. So what are we trying to do here? Well, these are the dimensions of our box. If we want to make a maximum volume, to find volume, we have to multiply all of those together. Remember, we said our height was x, we said our width was 60 minus 2x, and we said our length was 80 minus 2x. So what we need to do is multiply all of that together. Yeah, that's what I thought. Okay, so we're going to take and we're going to do x times 60 minus 2x, and we're going to multiply that by 80 minus 2x. And that's going to give us our volume. Okay? Now, at this point, you could leave it just like that. Okay? Because everything we do is going to be in the calculator. But recognize that in the future, you may have to multiply these together. You may have to FOIL. So if you have to FOIL, you FOIL. But at this point, you don't have to FOIL. So we're just going to, I'm going to do it anyway just to review. So we're going to have 60x minus 2x squared. And that's going to get multiplied. So the first thing I did was distribute the x. Now I've got that times 80 minus 2x. So what I'm going to do now is I'm going to FOIL that. So 60 times 48, or times 80, is 4,800. 60 times a negative 2x is a negative 120x. 2x, which is negative 2x squared, times 160 is, oh, this is 120x. This is 4,800x. This is 120x squared. And then this is going to be 160x squared. And then negative 4x to the third, or positive 4x to the third. And then when we combine like terms, we've got 280x squared plus 4x cubed. Okay, so that gives us a expression that describes our volume. So we're going to go back to Desmos, and we're going to type that equation in. So we've got y equals 4800x minus 280x squared plus 4x to the third. Now my window is kind of screwed up here, so I'm probably going to need to change my window. So maybe I need to take my x-axis. I don't care about any negative numbers, right? So maybe I need to go up to 50 or 45. Okay, I'm seeing something there at 45, and it looks like I need this to go up higher, maybe 150. I love Desmos in that I can just keep typing until I get something I like. Okay, got me a graph here now, right? So this is my volume. True? Now as soon as I click on that, look what pops up, my key points. Isn't that awesome? What am I looking for? Well, if we go back to our question said that we want to find the volume of the box. So here's our volume of the box. Now, when we look at this, if we want the maximum volume, where's the maximum volume going to occur? Well, our maximum volume is going to be right here. And that would mean our maximum volume would be 24,258.42 cubic centimeters. And that would occur when the height of our box was 11.31 cubic centimeters, or centimeters. So that would mean if we went back to our diagram, we could have a maximum height if x, so you could have a max volume if x equals 11.315 centimeters. And so if this is 11.31 centimeters, then our volume is 24,000, it was 25,000, wasn't it? One of you remembers. 24,258.42. 24,258.42 centimeters cubed. Now, why would you care? Well, let's say you're buying your mom a Mother's Day gift and you want to buy her a box of wine. Right now, this box of wine is going to take up 11 centimeters on her shelf in the fridge. But it's going to hold 24,000 cubic centimeters of wine. A cubic centimeter is a milliliter, so it's going to hold a little over 2 liters of wine. Not bad, right? So just a little something to think about. Okay, so what I'm going to do is I'm going to post this closure that you see here. I'm going to post this closure that you see here on its learning. And I'm going to ask you to answer it on its learning, and that'll be your grade. Okay? Thanks, guys.